Okay, let's finish this section 2.6 with the last operation, which is a composite, composing two functions. And so by definition, we'll use a symbol, which is this little circle here, to do compositions. F circle G. The compositions, the definition, is given as F circle G of X. This is still function notation, so it's not times X, it's F circle G of X. And the circle tells us to write F, parenthesis G, parenthesis X. And actually in words, what this is telling us is to take the G function and plug it back into the F function. So we're going to plug the G function into the F function everywhere we have an X. That's how F circle G is interpreted. If it were written G circle F, then it would be G parenthesis F parenthesis X. Notice F is inside, so that means we're plugging the F function inside or into the G function. So we need to know the order. F, G, X, G is inside, it gets plugged into F. G circle F means F gets plugged into G. And let's look at some examples on that. Let me clean up my statement here. So 2x minus 4 and x squared minus 2x. Let's do the operation F circle G, which by definition means F parenthesis G parenthesis X. And in words, what I have stated up there means I'm going to plug the G function into the F function. So let's illustrate that. I'm going to take the G function that looks like this and plug it inside the F function for every X. So every X in the F function is going to become what the G function looks like. So putting that in here for X, instead of 2x minus 4, I'm going to have 2 times x squared minus 2x minus 4. I'll put the G function into the F function. That completes the operation. Now let's just clean this up with the algebra. So 2x squared minus 4x minus 4 is what I have, and I can't add or subtract anything. That would be the result of putting the G function into the F function. 2 times G minus 4. Distribute your 2 and you're good. Now let's look at the other way. G circle F of X means G is outside and F is inside. Means I need to take the F function. I'm going to plug the F function into the G function. So let's illustrate that. Here's my F function. I'm going to pick it up, take it, and haul it over here and plug it into the G function everywhere I have an X. So there are 2 X's there. Both X's get replaced with the F function. See what that looks like. G of X says I have something squared minus 2 times something. The something that I'm plugging in is the F function, 2x minus 4. Both x's get replaced with 2x minus 4. And again, we'll need to do some algebra to clean it up, but that's the basic operation. We need to FOIL this out and go ahead and distribute it by 2. Distribute the 2. So we'll end up with 4x squared minus 16x plus 16 minus 4x plus 8. And we could clean that up. Let me check my arithmetic here. 4x squared minus 16x plus 16. Yep, and then distributing that out. 2 times 2 is 4, 2 times 4 is 8, positive, negative. Okay, so the result would be 4x squared minus 20x plus 24. Let's look at this one. F circle F. That one's kind of awkward, but it means F parenthesis X. So we're going to plug F into itself, F. Well, let's illustrate that. It's always good to kind of see how we can rope these things off and plug them in. So I'm taking the f function here, picking it up and plugging it back inside itself for x. So you're putting f inside of itself, f. So instead of 2x minus 4, I have 2 times itself minus 4. Put the f inside of itself for x. So we have 4x minus 8 minus 4, which gives us 4x minus 12. Just cleaning that up, combining terms. Finally, the last one on this sheet. F circle g, instead of f circle g at x, we're looking at f circle g at 3. So that means notation, it's f parenthesis g parenthesis 3. Well, just like with any set of grouping symbols, order of operations prevail, and we want to do the inside first. That means go to G and plug in a 3. So let's go to G, which is up here, and plug in a 3, which would look like 3 squared minus 2 times 3. 9 minus 6, which would be 3. So I just calculated the inside. I came up with the result, so the result I came up with is going to be placed inside the parenthesis. Now how do I finish this operation? I go to F and plug in a 3. So I'm finding f of 3, which would be 2 times 3 minus 4. So 6 minus 4 would be 2. I went to G and plugged in the 3 first. Found G of 3, which was 3. I replaced the inside part with the result of 3 and went to F and plugged in a 3. F was up here at the top, so it'd be 2 times 3 minus 4. So that's some practice on compositions. Let's do the last thing here for this section, which is decomposing functions. No, we're not going to watch the flies come. We want to actually take our function and break it down into its 2 basic parts. So here's what we have. They say, okay, I've given you a function that represents a composition. It's basically the answer of a composition. This h of x is the answer of a composition f circle g. I think it'd probably be best written this way. H of x is equal to the result of f circle g at x, which is by definition f of g of x, which they're telling me is 2x plus 5 raised to the 4th power. Let's think of it that way. So 2x plus 5 to the 4th power is what they're calling h, but it's the result of taking 2 functions and composing them together. We want to go backwards and find out what was f of x and what was g of x originally. What were the 2 functions originally that were composed to get me to that result? Well, let's think about it. Notice g of x is my inside function. So I need to think of this as an inside function. And then the f would be the outside function. The g of x will always be the equation that we come up with for the inside part. F will always be the equation for the outside part because it was f circled g. G was put inside f. Well, let's check this one out. It's pretty obvious here. What would you consider on this whole result, what would you consider being the inside part? I would actually call this part. That's my inside function. It's inside my parentheses. That's a hint. What would I consider being the outside part? I would say this part, this 4, is the outside part, that power of 4. When I break these down, or break it up into 2 functions, I need to write g of x as the inside function G of x is going to be the one that's inside. F of x is going to be the outside. Well, what did we say the inside looks like? 2x plus 5, so let's say g of x is 2x plus 5. We said the outside part was going to be a fourth power, but I can't just put a fourth power with nothing as my base, so I'm just going to say x to the fourth. Once you break it down into your two composites, we've decomposed it, check your answer. Take your 2 and do f circle g of x, which is f parenthesis g parenthesis x. Put the g inside the f function and see if you get what they defined h to be. See if you get the original result. And if I'll get that. If I take this g function right here and put it inside this f function right there, I'm going to get the original problem that they stated. So this can just be a check step. So there'll be several for you to decompose. Just always look for an inside part and an outside part. Don't forget to look at the practice problems from the book. The rest of the stuff can come from Course Compass.